Hope you are doing well. In today's physics problem, we are going to find the angular velocity at the highest point of the oblique projectile motion. Okay, so this is a really interesting topic because at the highest point, the vertical velocity of the projectile becomes zero. Still, the projectile is moving with respect to horizon with some velocity. So, how do we can calculate that angular velocity at the highest point? That exactly what we will figure out step by step. I will explain in the today's concept and logic that will help you to tackle the similar JEE problems with confidence. Coming to the solution, here a projectile is projected with an angular velocity of 20 meter per 20 root 2 meter per second at an angle of 45 degrees. Here the projectile is moving only with respect to gravity, and other than gravity, no other acceleration is affecting the path of the projectile, so that Ax becomes 0. From the first kinematic equation, Vx equals to Ux plus Axt. Here, ignore horizontal acceleration, then Vx equals to Ux. What is Ux? U cos theta. That is 20 root 2 cos 45 is 1 by root 2. Root 2 gets cancelled. Vx equals to 20 meter per second. From the equation, the relation between linear velocity v equals to r into angular velocity. That implies angular velocity equals to the perpendicular velocity divided by the distance with the horizontal. Here, the perpendicular distance is maximum height, and with the height, the perpendicular velocity is here Vx. So this is Vx or V perpendicular. From the relation H max equals to U square sine square theta by 2g in oblique projectile by substituting the values 20 root 2 whole square times sine square 45. Sine 45 is 1 by root 2. Sine square 45 is the 1 by 2 by 2 into g. Take g equals to 10 meter per second square. Then h max becomes 400 into 2 into 1 by 2 divided by 20. So this will become 20 meters. Therefore, angular velocity omega equals to, what is v perpendicular here? We got 20 meter per second divided by the perpendicular distance with the horizontal is 20. 20 gets cancelled, then we will get 1 radian per second at the highest point. So option 2 is the correct answer. Hope you understand the concept. Thank you.